I'm Kama Ross. I'm the district forester serving landowners in Leelanau, Benzie, and Grand Traverse counties. And today I've got with me Dr. Randy Schetzel. He is a professor of geography at Michigan State University. And this is the second time we've had Dr. Schetzel up here in the Traverse City area to talk to us about our glacial history and how that relates to forestry in particular, but the vegetation that we see today.
Okay.
So as a forester, I try to help landowners understand the productivity of their soil based on the vegetation that's currently growing. But maybe you can help us understand a little bit more about the difference between dirt and soil and what makes good soil.
Well, dirt is soil that's out of place, is what we always tell our students. But seriously, it all started out as sand up here, a lot of sand. Of course, there's places where there's clay or silty deposits, but primarily think of this as an area that when the glaciers left, that we call that time zero. And that's when soils start forming, at time zero. As soon as the ice left and the soils thawed out, the soils start forming. And so this system has moved from one that's just pretty much inert sand to one that is a biologically complex organism that we call soil. What's so complex about it is it's accumulated organic matter, it's accumulated nutrients, which can support the ecosystem that we know today. Biota live in the soil, whether it's microorganisms or macroorganisms like pocket gophers or snakes or other burrowing mammals.
And as we look at our current situation here, and everyone is talking about our climate change, and we are definitely seeing fluctuations in the precipitation, especially in the winter time. How does that affect this buildup of organic matter in our soil, the quality of our soils?
It's a very important question, one that a lot of people are studying right now, and a colleague of mine at MSU, David Rothstein in forestry, and I just completed a fairly large research project in the UP focusing on this particular point. What we hypothesized is that snow, thick snowpacks like we have here around Traverse City or in parts of the UP are very efficient at washing organic matter and nutrients deeply into the soil. Whereas in the eastern lower peninsula or the southern lower peninsula where snow is less reliable, we don't have a lot of water moving into the soil in spring, and so anything that snowmelt water could wash in doesn't get very deep. So what we did is we instrumented 18 different sites in the UP, sampling the water that has moved past a certain depth of the soil. And we do this frequently during the year, sometimes every few days. The upshot is the more snow that there is, the deeper this carbon gets pushed in. You would expect that. Mm-hmm. And those are the most fertile soils. So snow is, we think, the primary driver. And now, as we think about climate changing and snowpacks getting thinner, and we've seen that again and again, what we hypothesize will happen is that less of the carbon will be washed deeply into the soil. Carbon that's only washed in a little distance or a short distance is much more liable to be immediately oxidized and released back to the atmosphere. It's almost like a fire in certain ways. If you don't push that carbon deep, you lose it pretty quickly.
Okay.
And so if we're losing that carbon to the atmosphere, then it's not being stored in the soil. And storing it in the soil keeps it out of the atmosphere and keeps the atmosphere cooler. We know that soils store twice the amount of carbon as the atmosphere. Mm-hmm. So if I guess the upshot is as the climate warms, there'll be less snow. If there's less snow, more of the carbon is going to be released to the atmosphere, and that's going to warm it up some more, and it becomes what we call a feedback, where one thing makes another thing happen, and that makes another thing happen, and we're right back to the beginning, and next thing you know, the climate is in what we call a runaway system where it just keeps getting warmer and warmer.